Alright then, what I want to do here is to simulate some fluid going through a spiral in copper, copper pipe made in a spiral way. So we're gonna use some parameters like heat flux of 1997 watts per meter square, and copper water. We will use 400. Well, that will be our heat transfer coefficient, 400 watts per meter square Kelvin. And right, we're gonna use also our temperature. Our general temperature will be 22 Celsius, and we're gonna use also heat flux, transfer, general temperature. Alright, our copper air heat transfer coefficient will be 13.1 watts over meter square Kelvin. That's what we're gonna use. I don't remember another parameter. Oh yeah, the velocity of the fluid. So we're gonna say the water velocity will be 0.01 meters per second, or if we're gonna use the mass flow, it will be 1.3 kilograms per second. Alright then, let's begin. We're gonna use fluid flow fluent and define the geometry. We're gonna use the meter unit in national system, and we're gonna import external geometry file. For example, I have the parts, but I'm gonna use the assembly just to change something, because you can use the assembly in SolidWorks. This is SolidWorks 11. So we're gonna use generated. It will take some time while creating the parts. Okay, this is the pipe. So we can see here it's the fluid and the exterior spiral. Then we're gonna change the name. We're gonna rename this. This will be the spiral solid, and this will be the fluid. That's how I'm gonna change. I'm gonna call this, and the fluid will be fluid here, as you can see. Don't know what happened, but and the spiral will be solid. The fluid will be fluid. You can see here fluid, and this is the spiral solid, fluid solid. That's alright then. Generate it, and let's continue. This is update. Then we're gonna match it. What we want to do here is to simulate a exchanger. So this kind of exchanger is something which allows water to go through it, and with a heat source like radiation or some kind of heat flux like a heater or something like that, the water changes its temperature between the inlet and the outlet. And now doing that, we're gonna match it. We're gonna use some sizing parameters. We're gonna change it to fine, and smoothing like high, and slow transition fine. And we're gonna see what happens. We're gonna generate the meshing. This is meshing now. This will take a while, but it will be good. Alright, meshing is done. You can see here and statistics. You can see the nodes are 143,698 nodes. That's a good meshing. So go ahead. So now we're gonna create the surfaces, because when we are using Fluent, we need to create surfaces, define surface, and well, after that, we're gonna use them to define the whole boundary conditions. So for now, we're gonna suppress the body, spiral body. We're gonna have the fluid, and we're gonna select using Control and clicking. Now you can see here, Control and clicking, and select both faces, the elbow and the plane spiral of fluid. And now we're gonna create the surface. This will this will be the fluid surface. Fluid surface. We can call this the fluid interface also. That doesn't matter. It's even better to do this. So fluid interface. Okay. Now we're gonna create the inlet. Cursor mode. Now create name inlet and the outlet. Create name outlet. Okay. Now we're gonna suppress this body and create the and unsuppress the spiral body. You can see here all of them are related to fluid, which is suppressed. And now we're talking about the spiral solid. We're gonna create the what happened? Oh, generate mesh. We have to generate the mesh, and now we can choose here, selecting the bodies. This will be the, we're gonna call this the top surface. Okay, we're gonna call the create. This will be the spiral solid interface, and also we will have to create, this is just like a formal convention. We're gonna create, no, this is not the, this one and this one. We're going to call this the side surfaces, the side surfaces. Now we have top surface, external surface, the spiral solid interface, so the internal surface, and the side surface, which are in the inlet and outlet areas. Now we're gonna generate the mesh. We're gonna unsuppress the body, generate the mesh, and in meshing we're gonna do update. And doing that, we have now our meshing and our surfaces defined. So we can continue now. Now we're going to start the setup. So ansys, this version is ansys 14.0, as you can see, and this is creating the machine. This time it's working really quickly. I don't know why, but it's cool. So report quality, it is okay. It's not very good, but it's okay. And you can see here. Now that we're here, we can do the models. We're gonna use and turn on the energy equation, and viscous will be laminar because the fluid will go really slow, and radiation, it's okay. The rest we're gonna use now. We have to change this because the fluid database, we're gonna use liquid, water, liquid water, copy, and we're going to use solid and copy, create. We're going to close this. We will have to delete both of them, air and aluminum, but later. Now in fluid, the type will be fluid. Maybe we're gonna change, select water liquid, porous zone, and this will change for copper. Now we're gonna uncheck porous zone. It's okay. This will be necessary for the step of deleting these things because we're gonna try delete this. Oh, then and aluminum. But you can see here it is used now and then because now here spiral solid lead and you can choose copper because aluminum is not there. Fluid, you can check this again, water, liquid water, boundary conditions. Now here we go. Fluid interface, now we're not going to use it. Fluid interface will be an interface. You will have to define that. And that will activate the mesh interface. You can see here. Inlet, now the velocity inlet and edit. And we're gonna use we can use it like magnitude, or we can choose like mass flow inlet. We can do that also. The mass flow rate will be 0.3. And now we're gonna select normal to boundary. Don't forget to do that. And the thermal will be 300. It's okay. I think it will be like 297 actually. 295. Excuse me. 295. We can continue. The interior fluid is this interior. You have to leave this like it is. Interior the same. Outlet we're gonna use and change and put the general temperature value. Side surfaces, this will have to deal with convection, and as I said we're gonna use 15.1 and the temperature will be 295, and don't forget to use copper. The outlet, all of them, and they are not wall, so it's okay. But now side surface, yeah, we did this cooper, it's alright. Interface is an interface. You have to be careful with this. You have to select an interface because that is an interface, and don't change this name because this will affect the exercise and you cannot save this and reuse it again, so it's okay. And top surface, this is a wall. Don't forget to thermal heat flux. We're gonna use the 1997 watts per meter square and select Coupa. Now that we have done all of these, we can highlight the zone and we can see what we have done and where are they located. The inlet, okay. Now that we have this, we'll check highlight zone and well, we can go back and try to delete aluminum. It's okay now that it is not in use. and start with mesh interfaces. You have to do this if you want this to be a good machine and a good project, because otherwise you won't get any good results. You'll just waste your time without an interface that connect the solid with the liquid or the fluid, because this will let you see and let the program analyze both conditions and boundaries for them. So we're gonna use final, well, I'm gonna call this final interface, and I'm gonna choose here fluid interface and spiral solid interface. Don't forget that you cannot do this, select the same name, because that doesn't work here. This always creates an error, so it's okay. And do not choose anything here, because that is not good. That doesn't work. So it's just this. You can draw this, you can see the surface, you can create it, and after creating you can list it to see some data. That's just for reference, nothing else. So close it. Dynamic mesh, you can omit this. Reference values, it's okay. Solution, methods, solution controls, monitors, but here you have to be careful. And here you can see here the intersection zones. So these mesh are not created on initialization. So initialization is here. Solution initialization, as you can see. So intersection zones are not created on initialization. So that means that this meshing of the interface surface won't be created when you do this. And we're gonna use standard initialization because that is the safest way. So we're gonna choose top surface and relative to cell zone and velocity. We're gonna use 5 e minus 4, 5 e minus 4, 5 e minus 4. We're gonna leave this 300 and click initialize. Now that we have initialized, it's done. We can check these meshing interfaces to see what will happen. So we can click list, and now we can see. So now we can see here that something was created. There were 4 walls created: 13, 14, 6, and 6 shadow. Wall 6 and 6 shadow means that this was created. This is the real interface, and well, this boundary zone, I don't have idea about this. That must be something necessary. So we can see here we cannot change anything. Well, you can see here, but there's nothing to change because we, we cannot know where they locate. We can see this and we can see this, but anything else. Solution initialization, initialize, it's okay, continue. So we can go through this number of iterations. I don't know, probably, don't know, 150 for example, and calculate. Just calculating the solution, and now you can see the graph how this is done. Now we have the solution. We don't know. This is not the real solution actually, because it reaches the 150 iteration. So it's better to try another bigger number and calculate it. Okay, now that we have done this, we can check this out. So the solution in contour, setup, field, temperature. We can see here, for example, inlet, no, top surface, for instance, display, and this will show us how this is related to the temperature, and you can see also the temperature of the interior fluid, for example. We can see here, and we can compute the inlet and the outlet temperature. We can go to reports, surface integrals, area weighted, temperature, inlet, outlet, compute. So following this, we can say that the inlet is about 295 Kelvin, so it is like 22 Kelvin, and the outlet it will be 567. Just taking into account that it will take a long time doing this in a constant way of the heat flux. So this is just data, and you have to analyze this. But now you can do this and try another kind of exercises, or try to solve some exercises from another sources to check this out and to learn how to use and to how to compute your exercises and your problems to solve real problems, of course. So hope you the best. So thank you for watching. See you later.